Okay, now let's start with problem 20. And we want to use a calculator to find the decimal approximation for this trig function. And it uses some kind of notation that I need you to be aware of where to find on your calculator. So this says cotangent, but suppose it said tangent of 228 degrees and 48 minutes. Let's just do that. So I'm going to hit my tangent function. I'm going to click 228, and to get my degrees, I'm going to go to second angle and choose the degree mark. Press enter. Then I'm going to type in the 48, go to angle, choose number 2 to give me my minute mark. Now I've got the tangent of 228 degrees and 48 minutes. And so if I press enter, that gives me my value. Well, if I know the tangent, how do I find the cotangent? All I have to do is take the reciprocal because they're reciprocal functions of each other. So at this point, I've got the tangent of that value, so I can use this button, x minus 1, that takes the reciprocal of it, and when I do, I end up with that as my answer. And guess what? This would be the perfect answer if my calculator would have been in degree mode. But my calculator was not in degree mode, it was in radian mode, so this is incorrect. So the correct answer, if your calculator would have been in degree mode, the correct answer you would have gotten by following this procedure is 0.8754. So, word to the wise, make sure your calculator is in the correct mode. And let me check that again. Number 20, 0.8754. Okay, so don't do like me in that. Okay, so we want to do the same thing, decimal approximation for secant of negative 109 degrees, 7 minutes. Well, now that I'm in the correct mode, secant is the reciprocal of cosine. So I'm just going to do cosine of, where's my little negative? Let me get that. Negative 109. Let me go to angle, get my degree mark. Let me put in a 7 and get my minute mark. And again, since I'm in the correct mode, I should eventually get to the right answer here. Okay, so that's what cosine of that angle is. I want secant, so I'm going to do the inverse by pressing x minus 1 to flip it over. And that is the correct answer. Negative 3.0535. Negative 3.0535. Okay, question 22. We want to find the decimal approximation for 1 over cotangent of 28.6. Well, I know that 1 over cotangent is the same thing as tangent. So all I need to do is find tangent of 28.6. Now, when you don't have the degrees, minutes, seconds, you don't need to pull up the degree mark and type that in. Your calculator will just look like this. Tangent of 28.6. You're in degree mode, so you're good to go, and the decimal is 0.5452. Let's check out 23. This is a totally different situation. We're trying to find theta. In the previous problems, we knew the value of theta. Now, oh my God. My cat's throwing up. Sorry about that. That's gross. Totally lost my train of thought. Oh, in the previous problems, we knew theta, so we just hit tangent of some theta. But in this case, we want to find a theta such that when I take sine of that theta, I get this result. That's when we use the inverse. So when you're trying to find theta and you're dealing with decimal approximations on your calculator, you have to use the inverse function. So if sine theta is equal to this value, then theta is equal to sine inverse of that value. And so if we pull up the sine inverse, type in that value, we get 38.87667247 as our degree measure, because remember, we're finding theta. This problem says to round to the nearest sixth decimal. I'm not doing that. I'm just saying it's 38.88. Cat, please. Oh, God, let me pause this. All right, the cat's done over there. So I'm just rounding to 2 decimals, even though the problem said to go to 6. I'm just taking a little light on this one. Okay, so let's look at 24. 24 is a little squirrely, so since it's not your cosine, sine, or tangent, we have to first take it and write it in terms of a cosine, sine, or tangent. Then we deploy the inverse. So I know if I've got secant alpha in this case, secant alpha is the same thing as 1 over cosine. Or I could say cosine is 1 over secant. So I want to write the secant in terms of a cosine, so cosine is 1 over secant. Well, I know what the value of secant theta or secant alpha is. It's this number right here. So if secant alpha is this, cosine alpha is 1 over that. Now that it's written in terms of a cosine, then we deploy the inverse cosine of that result on the right, 1 divided by 1.4935195. It's the cosine of that amount, and when you put that in your calculator, you should get 47.97 degrees. And again, I'm just rounding to 2, even though it says 6, you're welcome to put 6. Okay, let's look at some right triangles. What do we know about right triangles? What information, what formulas do I need to know? I know that the hypotenuse is across from the right angle, and it's always the largest side. And I know when I'm dealing with my sides, if I have an angle M, then side M is across from it. And if I have an angle N, side N is across from it. And depending on where my angle is, I can have opposite, adjacent, and so on. So the first thing is to find the measure of M. Well, we know that that triangle, the measures of the inside of the angles inside of a triangle have to be 180. And we already have a 90 degree. We already have a 48.2 degree. So to find the third angle, we just need 180 minus 90 minus 48.2, and that will give us our angle for M. So angle M is 41.8. So we have all our angles. Now let's set up a function, a trig function, to help us find our other sides. So I'm going to work with 48.2. So let me go here. I'm going to work with this angle right here, which is angle N, and I want to find a trig function that deals with the opposite side of that angle and the adjacent side, opposite and adjacent. Because I know adjacent is 126, and I can find the opposite. So what trig function deals with opposite and adjacent? That's tangent. So let's use the tangent function to find side N. I know that the tangent of that angle, which is 48.2 degrees, is going to be equal to the opposite, which is N, over the adjacent, which is 126. tangent is opposite over adjacent. I can take this and very easily solve this for n. Do that by multiplying both sides by 126. So, work on calculating that value of n. N is equal to what? Did you get side n to be 141? We get 140.9, but it says to round to the nearest integer, so we'll round it to 141. So look at what we have. We have this side of our triangle. We have this side of our triangle. Can we find the hypotenuse? Yeah, pull in old Pythagorean. 141 squared plus 126 squared is equal to p squared in this case. Go ahead and find side m. So for that side I get 189.09, and it says to round to the nearest integer, so I'll call it 189.09, or excuse me, 189. And there's our right triangle. Setting up the triangle for 26, I've set that up. You can see the figure on the right. You got to remember that little side A is across from angle A. Little side B is across from angle B. You got to get those in their correct positions. Well, one of the first things I can find is once I know A and B, I can find C using the Pythagorean theorem. So go ahead and do it. You should get C equal to 88 when you use the Pythagorean theorem. Now we need to work on angle A and angle B. So let's just put, here's our theta right there. I want to use a trig function. Theta is going to actually be what I'm looking for, so it's my variable. So I need to set up a trig function for theta. I could set up any one, sine, cosine, tangent, it doesn't matter, because I have the values of all my sides. Let's just go with sine. Sine theta is equal to what? Opposite over hypotenuse. So opposite is 77.2. Hypotenuse is 88. So sine theta is equal to, let's see, 77.2 divided by 88. And we get sine theta is 0.87727727. So that's what sine theta is equal to. But remember, anytime you have to find theta, you need to deploy the inverse function. So theta is going to be sine inverse of 0.87727727. Find that. I come up with theta to be 61.31 degrees. Forget about what it says here about degrees and minutes. We are just going to say it's 61.31 degrees. Or we could even just say 61 degrees. So I could either say 61 degrees or 61 point whatever it was, 61.31. Just depends on the problem, but I am not going to make you do minutes, degrees and minutes on that. Okay, so let's go with the whole number. Let's just go with that whole number, 61. So if angle A right here is 61 degrees, you're good to go to find B, because C is 90, A is 61. So how can I find my one that's missing? 180 minus 90 minus 61. So that second angle turns out to be what? The 20? Why do I have all these different numbers on here?